Hello everyone, I'm Mona, and here we are together on the Textiler channel to learn what categories of fibers are, identify them, and be able to recognize different fibers. So stay with me. The 4 sections of fiber identification are as follows. 1. What is fiber? 2. Categories of fibers. 3. Main properties of fibers. 4. Types of yarn production systems. In this lesson, we are focusing on the classification of fibers. Let's get started. There are 3 main categories of fibers: natural fibers, regenerated fibers, synthetic fibers. Natural fibers are those that come from natural sources, where the fiber is formed directly by nature, such as cotton, wool, silk, and so on. Regenerated fibers have a natural origin, but require modifications by humans to meet the parameters of a fiber, as described in the previous section. These changes make them generally fall under the man-made category. Viscose, acetate, and similar fibers belong here. Synthetic fibers have an artificial origin, produced by connecting the polymers of chemical materials to create substances with fiber characteristics, which can be spun into yarn and used as fabric or other textiles. In the next slide, you will see a full classification of fibers. As you can see, natural fibers are themselves divided into 3 categories: plant-based, animal-based, and mineral-based fibers. In the following slides, we will examine globally common fibers one by one to get familiar with their properties and features, so that when we see them around us, we can recognize them. This recognition is very important in determining their proper application. In plant-based natural fibers, we have several types, the most important of which are cotton, a seed fiber as it naturally grows from a plant seed, considered one of nature's wonders. Flax, a bast fiber where the plant's bast can be transformed into textiles. Jute and hemp, also bast fibers, known for very high strength. In fact, some high-strength synthetic fibers were inspired by their structure. Cite, a leaf fiber with specific uses. Coir, obtained from the coconut fruit, also with its own applications. Among these, cotton, flax, and jute have the widest range of uses. Another type of natural fiber, animal-based fibers, includes sheep wool, mohair, and silk. There are also other fibers in this category, but these are the most common. Mineral fibers include asbestos, which has special industrial applications, though its use has declined in some countries due to health risks. In man-made fibers, we have the regenerated group, which come from natural origins. In later slides, we will cover the most common ones and examine their properties. Of note here is the protein fiber derived from milk, which can have therapeutic properties and has its own unique production process. For synthetic fibers, the most common is polyester, used in all kinds of home textiles, clothing, industrial fabrics, and more. While it can never match cotton in terms of skin compatibility, in some garments it is an unrivaled competitor because it has good drape and high adaptability. Inorganic fibers in the man-made category are mostly used in industry, and we won't focus on them in this lesson. Stay with us in this lesson so that, by the end, you will be able to identify all the textiles around you and decide which fibers to use for each purpose. In this slide, we will examine cotton fibers, which have a cellulosic nature. In fact, in terms of internal structure and growth, they are still plants, and their entire essence lies in bridging the world of plants with the parameters accepted for fibers. Now, it's time to review their characteristics one by one. The most common fiber in the world, soft and fluffy. Cotton farms require a lot of irrigation. For this reason, they can only be cultivated in specific countries. Just as plants and fruits do not grow in every climate, cotton also follows the characteristics of its own botanical family. Quickly absorb and release moisture. These fibers, much like plants, contain an internal pathway for water flow that enables them to complete their growth process, absorbing and retaining the necessary minerals and nutrients from the soil. However, note that this channel is solely for water retention inside the cotton, not for water transportation. It is called the lumen. This hollow space remains even after harvesting the cotton plant and continues to exist within its structure, allowing water to pass through the fiber and enter this space. For this reason, cotton is considered a highly hydrophilic fiber. Breathable. This feature is due to the fact that fabrics made from these fibers can easily allow oxygen to pass through, making them breathable. As a result, cotton fabric is very suitable for the body. It absorbs sweat, transfers it to the environment, and thus participates effectively in the natural biological cycle of the human body. Of course, keep in mind that as fast as cotton absorbs water, it is slow to dry, which is why cotton clothing feels heavy in a humid environment. Good dyeability. As mentioned, these fibers have the capacity to hold water, so any substance dissolvable in water can easily penetrate them. Moreover, the molecules of the fiber are able to bond with dyes under specific dyeing conditions. Mercerization process. In their natural state, cotton fibers have a bean-shaped cross-section. We will look more closely at these types of properties in later sections, but it is this shape that prevents the fibers from having any notable luster or shine. This is due to the same internal hollow space that causes the fiber to form a bean shape. To address this and change the fibers into a round cross-section, the mercerization process is applied. This transforms cotton fibers from a dull, matte appearance into a state with acceptable luster. This operation is performed on yarns and primary fabrics, and the substance used for this process is sodium hydroxide. Can be wrinkled and change dimensional stability. When these fibers are placed together, their hydrophilic nature allows them to change dimensions or move against each other within the yarn or fabric structure, leading to dimensional changes. Cotton base color is white, cream, yellow, and brown. Because cotton fibers are natural and contain various substances on their surface, their initial color is not always pure white. Therefore, certain chemicals are needed to remove these natural impurities. The breed of cotton must also be considered, as some cottons are naturally colored, other than white. Overuse of chemicals can damage the fiber structure, so for bleaching, hydrogen peroxide can be used. Different degrees of maturity in different breeds. As mentioned earlier, cotton fibers are similar to plants and fruits. Just as fruits can have varying degrees of ripeness, cotton fibers can also display different stages of maturity, even within the same boll. The extent to which each fiber has received water and minerals determines its growth and its ability to fully develop its structure. There are even semi-mature fibers, which may differ in internal structure and length depending on their maturity level. Regarding cotton breeds, each fiber exhibits certain characteristics based on the climate and environment it has grown in. This results in different varieties of cotton depending on the country where the cotton fields are located, such as Uzbek cotton, Indian cotton, and so on. Different lengths of fiber. Fiber length is a very important parameter in spinning, as shorter fibers cannot be properly integrated into the yarn structure and may protrude, creating fuzz on the surface. Fibers longer than the optimal length can damage the spinning system. The optimal length for cotton fibers is on average about 20 to 25 meters, and fibers up to 32 millimeters are considered long cotton fibers suitable for spinning. Fibers longer than this may wrap around the machinery and reduce yarn uniformity, causing operational problems. Staple fiber. The most important point, as noted in the previous section, is that fiber length is a key parameter in classification. Cotton fibers are categorized as short fibers and have their own specific spinning systems, which will be discussed in the section on different yarn production systems. The next fiber is flax, which is a type of bast fiber. Now, let's examine the characteristics of this type of fiber. The strongest stem fiber. From the flax plant, base color ranges from cream to brown. Difficult to dye. The structure of these fibers is designed for high strength, which makes them difficult to dye. They are essentially long polymer chains bonded together to form the fiber structure. This molecular structure has two forms, amorphous and crystalline. The more amorphous structure a fiber has, the more hydrophilic it is, and the lower its strength. Conversely, the more crystalline a fiber is, the less hydrophilic and the stronger it becomes. Flax fibers contain a higher proportion of crystalline regions, making them both non-hydrophilic and harder to dye. Since dyes require an aqueous environment to form molecular bonds with fibers, moisture absorption and wicking. Overall, due to their natural origin, these fibers have good moisture absorption, although not as much as cotton. Breathable. Luminous. The cross-section of these fibers reflects light to a reasonably good degree. Various fiber lengths. Because they are natural, they can have different lengths and are spun using systems different from those used for cotton. Staple fiber. These fibers are also classified as staple fibers. An important point about flax, and about flax yarn and fabric, is the linen fabric. Linen is well known for being thin and having properties similar to cotton fabrics. One might wonder how fibers with such thickness and strength can be transformed into a delicate fabric like linen. Of course, linen fabric itself retains a high level of strength, but it's important to note that after harvesting, fibers undergo finishing processes to achieve the desired fabric properties. Let's move on to the next fiber, so stay with me to learn more. This fiber is obtained from sheep and other animals with similar physical characteristics, such as mohair from Angora goats, cashmere wool from cashmere goats, camel hair, and so on. These fibers are animal-based and of a hair type. They may be washed and cleaned either after being removed from the animal's body or during the spinning process, because they contain fats and impurities that must be removed. Wool fibers, when blended with synthetic polyester fibers in different ratios, can produce worsted yarn. Air and heat preservation. Due to their highly scaly structure, wool fibers prevent air from passing through woolen fabrics. Therefore, if a piece of clothing or fabric exhibits certain thermal properties, it is essentially because the fibers themselves possess these characteristics. Furry and scaly. Base color, cream, yellow, brown, mixed. Different breeds. Depending on the animal species, there are different breeds of wool, each bringing its own inherent properties to the fibers. Different lengths of fiber. Staple fiber. These fibers are also classified as staple fibers, but they have different lengths compared to cotton, and their spinning system is different, which we will cover in later sections. Let's move on to the next slide and explore the beautiful silk fibers and another extraordinary gift from nature. Let's examine the characteristics of these fibers together. Luminous fiber from the cocoon of the silkworm. These fibers have a triangular cross-section, which reflects light like a mirror when it strikes the surface, giving them a bright and lustrous appearance. Wrinkle-resistant. These natural fibers are filament fibers, so they can have properties similar to man-made filament fibers. Unlike most other natural fibers, they do not easily lose their smooth, elegant appearance. Moisture-absorbing and repellent. High strength. Good dyeability. By nature, this fiber is hydrophilic, soft, shiny, and smooth to the touch. Filament fiber. Silk is the only natural filament fiber and has its own special spinning method. This fiber, which is the cocoon of the silkworm, is collected, cleaned, and then spun through a unique process. From the very beginning, these fibers naturally exist in a yarn-like form, requiring only the unwinding of the cocoon, unlike other fibers which must be combined, twisted, and drawn before becoming yarn. The next fiber we will discuss is a regenerated fiber known as viscose. This fiber has properties similar to cellulosic fibers because it is derived from cellulose, essentially obtained by processing and fermenting wood pulp. It is highly hydrophilic and loses its strength if kept in a wet environment for extended periods. Let's review its characteristics together. Derived from wood pulp. Soft feel and low strength. Prone to wrinkling and reduced dimensional stability. Quick moisture absorption and release. Silky and shiny. Due to its special and unique cross-section, it reflects light effectively. Breathable. Good dyeability. As a result of its high hydrophilicity. Staple fiber. This fiber is widely used alongside other fibers. Not only does it have applications on its own, but when blended with other fibers, it enhances their properties and improves the spinning process. The next fiber we will discuss is acetate, which is also a regenerated fiber. Let's review its characteristics. Acetate fiber, man-made substitute for silk. If polyester fibers are manufactured with a cross-section similar to silk, they can replicate the feeling that silk fabrics provide. However, in terms of hydrophilicity, polyester fibers inherently lack this property. Obtained from refining wood chips, smooth and soft, prone to wrinkling, low strength. Because these are regenerated fibers and highly hydrophilic, their overall strength is not considered high. Therefore, if a fiber has one desirable property, it may compromise other positive properties. Staple fiber. Although the production process of both acetate and viscose fibers can yield filament form, which we will discuss in other sections, they are usually cut into short lengths and used as staple fibers in spinning systems, either alone or blended with other fibers. Let's move on to another highly versatile fiber, polyester. Its features are as follows. One of the most widely used fibers. A synthetic fiber derived from petroleum that can be processed into granules. Depending on the nature of the material, polyester fibers have different types: DTY, POY, FDY, ATY. Polyester fibers can be produced with varying characteristics based on adjustments made to the production process, such as the stretching applied by the manufacturing machine, the level of crystallinity of the fiber, the ratio of crystalline to amorphous regions, and the process of texturing, which adds bulk, crimp, and waviness to the yarn to make it feel more like wool or cotton. These variations are achieved by making slight modifications to production parameters to meet the specific fiber properties needed. DTY, draw textured yarn. The production process creates a bulky yarn with a soft, cotton-like feel. POY, partially oriented yarn. A semi-drawn yarn that can be used as a raw material for texturing and producing DTY. FDY, fully drawn yarn. A smooth, shiny yarn that is fully drawn. ATY, air-textured yarn. A coarse yarn with more upholstery, curtain, or heavy apparel applications. Produced from FDY or POY by air-jet texturing. All these variations come from the same polyester-based material, and by changing only a few parameters, we can produce multiple types of polyester fiber with different properties, low moisture absorption, and quick drying. Due to the higher proportion of crystalline regions, polyester has higher strength and lower hydrophilicity compared to other fibers, especially natural fibers. resistant to wrinkles and sunlight, can be produced in different lengths and strengths. Staple fiber and filament fiber. Although polyester is manufactured in filament form, it can be cut into any desired length using other machinery to match the properties required in the final product. In this slide, we examine polyamide fibers, commonly known as nylon. Their characteristics are as follows. The final products are often women's socks and swimwear, a synthetic fiber derived from petroleum that can be spun, with raw material in the form of granules, high strength and elasticity, wrinkle resistant, soft and smooth, can be produced in different lengths. Staple fiber and filament fiber. Although nylon is produced in filament form, it can also be converted into shorter lengths if needed. Two commonly used types of polyamide are nylon 6 and nylon 66. The difference in their chemical structures results in two distinct types of polyamide fiber. Nylon 6, with fewer crystalline regions. It is softer than nylon 66, which has more crystalline regions. Properties such as melting point, tensile strength, dyeability, and moisture absorption depend on the level of crystallinity. Nylon 6 has lower melting point and lower strength, but better dyeability and better moisture absorption because of its lower crystallinity. Nylon 66. Due to its higher crystallinity, it is generally stronger and is often used for industrial applications. In this slide, we examine acrylic fiber, which is a synthetic fiber. Let's look at its features. A synthetic fiber similar to wool, often used as a wool substitute. Synthetic fiber derived from petroleum that can be spun. Raw material is in the form of granules. Quick drying, high strength and tear resistance, resistant to insects and mold, can be produced in different lengths. Staple fiber and filament fiber. Like other synthetic fibers, acrylic is produced in filament form, but can be cut into shorter staple lengths. However, due to environmental pollution and high production costs, production of acrylic fiber has been limited in some countries. Many companies have shifted towards producing polyester instead. It is also worth noting that during the production process, acrylic fibers can pose health hazards to workers, potentially causing occupational diseases. We now move on to the next slide, which is about a fiber that is mostly used in industrial applications because it has high strength and very low hydrophilicity. Polypropylene fiber, a synthetic fiber derived from petroleum that can be spun. Raw material in the form of granules, most commonly used in carpets, rugs, ropes, and wherever very high strength is expected from the fiber. Quick drying, high strength, cannot be dyed in an aqueous environment. In the next sections, when we examine fiber dyeing, we will understand that one method of dyeing is by mixing white granules with colored granules. This is how dyeing of polypropylene fibers is done. When the granules are melted in their production process, only at that stage can we dye them, and the colored granules are mixed according to the required color shade. The resulting filament fibers come out colored at the end of the spinning process. However, after receiving polypropylene fibers, under no circumstances can we dye them or dye them in an aqueous environment with special dyes. Can be produced in different lengths. Staple fiber and filament fiber, produced in filament form with the possibility of property modification through texturing and length adjustment with cutters. The next fiber we will examine is spandex fiber, which has elasticity, and if placed alongside other fibers, it will also transfer this property to those fibers. And in the structure of fabrics and textiles, it acts in the same way. In this slide, we will examine its properties, so stay with us for the last widely used fiber in this part of the training. Spandex fiber, a synthetic fiber derived from petroleum that can be spun. The raw material is in the form of granules. When in the fiber state, it can be stretched to more than 500% of its length. also known as elastane and Lycra, can be used alongside yarns made from other fibers to create elasticity, can be dyed. Filament fiber. This fiber can be placed alongside other fibers and yarns, or incorporated within the yarn structure to create elasticity. Depending on the application, one of these two options is selected. Don't forget to subscribe to our channel and ring the bell so that you stay updated with the training sessions.